All right, so we've rubbed the sugar cubes together, we've dripped water on them, and you've written what you believe this represents. Okay, now we're going to learn more about weathering, erosion, and deposition, and see how right you were. So weathering, first of all, is the basic part of the rock cycle. This is where the breakdown of rocks begins, and it's critical. It's an external process. It occurs on the surface of a rock. Things don't weather from within. It's external to the rock. Weathering occurs when the rock is mechanically fragmented, like your sugar cubes rubbing together, or chemically altered or decomposed. You were led her astray. That is an appropriate word.
I love doing that.
So when it's chemically altered. Now your sugar cube, was it technically chemically altered?
No.
No, it was dissolved. And that is still weathering.
So that technically is a dissolved.
Yep, because it was not chemically altered.
But could you say this is, oh, sorry.
Go ahead.
Could you say though this is a model? You use it as a moment, teaching moment to describe models represent something.
Yes.
You can't do it whenever it is.
Now if you take a rock, and we have a picture here of a rock in a towel, so when you break the rock with your hammer, it's not shattering everywhere. Just keep that in mind. And when you're doing your own cleavage and fracture tests, that's something you can do if you have the supplies. So the process of breaking the rock samples with a hammer simulates mechanical weathering. And a lot of times you see this or hear about it as physical weathering. Those words are used interchangeably. So physical weathering and mechanical weathering are the same thing. So did the composition of the pieces, like your sugar cubes, think about your sugar cubes. When you rub them together, did the composition change?
No.
No. Yes. So I want you to think about what is a good definition for mechanical weathering. You don't have to write anything down. Just think about what is a good definition for mechanical weathering. I'm calling somebody, and Alyssa's name jumped out of the bucket, literally jumped out. Alyssa or Melissa? Alyssa.
That means you're yes. I would say maybe things like the physical properties or the way it looked.
Okay. Did your sugar cube, when you rubbed it together, did it change into something else, or was it still?
It was still sugar, but physically it changed the way it looked.
Okay. So the
size.
The sizes of the pieces. Yes. Okay. Good. Thank you. Ashley B is not in the house. So Brandon S. Do you have anything to add to Alyssa's definition?
Physical weathering, yes. I mean, obviously it changes the appearance of it. Could you say that it puts the material in a different form for another purpose?
Yeah, that makes sense.
Right. So I'm saying the cubes can be used for one purpose, and by rubbing them together, I can take the same material and use it for a different purpose.
Sure. Okay.
So changing the physical appearance of it, which may also give the material a different function.
That's a good point.
Right, because I can use this for something, like, but I'm not going to be able to put this on food or anything.
Well,
whatever. You know what I'm saying? Yeah. Changes it.
Right. Okay. Thank you. So is mechanical weathering, is this a chemical process or is it a physical process?
It's physical.
It's physical process. Yes, very nice. Okay, now, with these physical processes, when rocks are broken up, mechanical weathering, one of the things that can cause this is frost wedging. Have y'all heard of frost wedging? Or ice wedging, maybe? Whenever there's a crack or a crevice in a rock, water comes in. When water freezes, it expands, so it pries apart that rock just a little bit. And then the water melts. Water flows back in, and it freezes, and it wedges it apart just a little bit. So time after time, that repeated process, eventually that rock cracks open. So that is frost wedging. There's expansion resulting from unloading, and this is what happened at Enchanted Rock. So this huge granite intrusion was covered by masses of earth. And when that earth was removed, then the pressure was no longer there, and so the rock can expand a little bit, and when it does, it causes these exfoliation sheets. So if you've been to Enchanted Rock, and we're going to see Enchanted Rock this week, you see these sheets just, it looks like they're just peeling off like an onion. Yes,
So,
ma'am.
how do you work with, because this is the real world, so therefore it's messy, it's not perfect. Whenever you have the water go in and it freezes, yes, that's physical, but if the water isn't pure because of pollutions, then it's actually a combination of mechanical and chemical because the pollutants in the water are also breaking down the rock.
But that's a different, I mean, that's,
Like, so whenever I was trying to do the report before they took the science test, there's just a picture. And so the kids are bringing up all these exceptions. There's a root going in that's trying to impart, well, that's supposed to be mechanical. But they're like, well, doesn't the root have stuff in it that also breaks down, which is also chemical? How do you deal with the overlap?
I guess that's one of those, which of these best illustrates. Because you're right, it is interconnected and it's all complicated, but you have to be specific about which one
The only one that picture that the kids didn't question me on was the wind. Whenever it came to the water or the plant or anything else, couldn't that also? Cookies for you. You know, you're thinking, but you're making my life difficult, so.
So that's the question. Yes. Okay, thermal weathering is another type of weathering. This is the repeated cycles of heating and cooling. It causes rocks to contract and expand, and eventually the rocks crack. And you hear about people, going into caves in the winter and making a fire, and then the rock breaks off on top of them. I mean, these were horror stories. I heard camping as a kid, and I was like, that doesn't make sense. It's a rock. A fire shouldn't make them break, but the repeated cycle of heating and cooling makes that rock contract and expand, and they can crack. Lichen. So the biological activity, and you see this a lot on rocks, and you see lichen on trees, and so the lichen is a pioneer species in primary succession. When you see that, that's the first species that comes in that grows on rock. It doesn't need the soil. And this lichen is photosynthetic, and one of its waste products is a weak acid, and this weak acid sits on the rock and dissolves it a little bit. And so that's that beginning of the soil cycle. The sediments are formed from the lichen. So the roots too, like you were talking about, Brenda, the roots grow in and they wedge apart the rocks too. Animals do some weathering, some physical weathering to the rock as well. Ant mounds. How might this be related to physical weathering?
The ants bring individual pieces of sand up to the top to hollow out whatever their bin is needed.
Okay, that's good. Good, thank you. Sidewalk cracking. While your sidewalk is not a rock, it's concrete typically. This is an example of how the roots can alter the state or the physical state of that sidewalk. My driveway is a multi-layered driveway because of a tree that was planted 15 years ago, a small tree that now is a big tree, and they didn't plant it far enough away from the driveway. An expensive problem if you fix it. Here's a
Throw more
basin.
concrete on it.
Level it off. The San Antonio construction site there, how might you see physical weathering here, mechanical weathering here?
The bulldozer is physically like digging out the rock and moving it to a different location.
Okay, okay,
Wind,
wind, okay. Anything else? So Melissa says the bulldozer is scraping out the rock, and when you scrape out the rock, you're making it into smaller pieces, right?
Exposing new rock to
And you're
the
exposing
weather.
new rock to the elements. And then Ashley says that the wind acts on it as well. Okay. So here is physically weathered granite on this side. And this is physically weathered rhyolite. And remember that it's the same mineral composition. It's just one of them is super fine grained and one of them is coarse grained, right? So you can see in the granite, when it breaks up, and you saw this in your crushed granite, it breaks down into its individual mineral components. Like a piece of feldspar would come off, and a piece of quartz would come off, and you'd see little mica flakes. In rhyolite, though, even though it came from the same chemical composition, it cools so quickly that those individual mineral grains are so small that it doesn't break into those mineral grains. It breaks into chunks of rhyolite. So you see weathering of the same chemical composition of rocks. It acts differently depending on the grain size. So the rock fragments are related to, like in the granite, the crystal size, the degree of cementation of the rocks, and that's only in the sedimentary rocks, the abundance and spacing of fractures in the parent rock, so how broken up it is, how cracked it was to begin with. So both the granite and the rhyolite, when they were physically weathered, they were still made up of the same chemicals. The chemical composition did not change. That's what defines it as mechanical weathering. Nothing new was created, nothing was changed. It's still broken pieces of granite and broken pieces of rhyolite. Here's chemical weathering. Now we're switching from physical to chemical now. So in your sugar cube with the water, it broke down. It doesn't look like sugar anymore, does it? It looks like a blob of goo. So here we are with water. This is just water dripping on a piece of granite. And over time, you can see that pieces of it do weather away. The water does, in fact, dissolve some of the minerals in the granite. Halite, the one that we could not do the water displacement test on because it's salt and will dissolve. Do you see how the water has impacted this one even more than the granite? Because it dissolves more quickly, it chemically weathers. Yes?
I'm lost as far as why that's going to be chemical weathering, but this sugar cube in water was not chemical weathering.
Well, see, that's the thing, is that it's not technically a new substance. It's dissolved, but that one, for whatever reason, falls under the chemical weathering.
You're saying that the halite falls under chemical weathering while the salt does not.
If this were in a textbook and it were a mineral, it would be categorized as chemical weathering.
Yes. I mean, because that's the way I taught it, so I was wondering why I was wrong, because that's...
I don't think you are wrong, because that's the way it was. I mean, when you read about chemical weathering, water dissolution is going this will fall into it. But much of the chemical weathering because of water is a chemical reaction, because there's other stuff that is in the water.
Yeah.
But this illustration right here is, we're modeling.
Because it is the physical breakdown. I understand.
It is, yeah.
I understand it from either aspect. I'm just wondering which when we teach it, which is a teacher question, I understand, but I was confused because the presentation, and then
Right.
earlier you said it's not.
Yes, and defined, it is a chemical reaction, there has to be a new product made,
Yes.
right? And there's not a new product made here. There was not a new product
Yeah.
made in there, but we're just modeling
The process.
the process. Yeah, because the water that would, Quentin, I don't know.
No, I understand what you're saying, and it's a hard thing to show within the classroom. This is an easy way to model chemical weathering. So I
Right.
understand exactly what you're saying.
So halite is an evaporite mineral, so it's formed from water evaporating. So I guess when water dissolves it, I don't know. Dr. West?
Typically with the sugar and salt, you might go back and let it evaporate so that they see the sugar is still
Still there.
there even after the water evaporates. So that might be a possibility.
But then it
And
was-
I have a question after.
But then that would still make it physical weathering, though.
Yes.
Yeah, it's about that line, is it chemical or physical? Because there's not a chemical change, but chemical weathering is defined as a chemical change occurring within the mineral. But I would argue that a lot of the chemical weathering is, like this, and with some other things, you're gonna see that, water is an acid that.
It's the main form of chemical.
Right,
Mode.
yeah. Yes.
So this again was an example of physical weathering. And this is an example of chemical weathering.
Well, yeah, and I have opened up a can of worms that I should have not opened. Yeah, okay, so here's the thing. The definition of chemical weathering is something that results in a chemical change. But we have not observed a chemical change yet. But in textbooks, and maybe we need to look it up in the textbook and see what the textbook says, how it categorizes this water dissolution.
So those materials that make up a piece of granite, if exposed to weathering, let's say one of the substance, whether it causes that substance to erode. So then the piece that's left is made up of something different, right?
Yes. So in the granite, you're saying some of it goes away and some of it's left behind
Right.
from the water?
Chemical,
Exactly.
Different.
Right. They weather differently. So whenever you go to the beach, you're looking at all the sediments that made it down the rivers and other stuff was left behind. And the reason that those sands were not dissolved is because they're more resistant to weathering, right? So all the minerals were dissolved away or moved away, or they're finer, and those bigger pieces that were left as sand are typically quartz because they're harder, they're more resistant to weathering. So I will look at chemical versus physical with water.
Is that the same thing with limestone? That corrodes your pipes or corrodes them all? Or is that through chemical weathering because there's many impurities in it?
This, it's not weathering, it's,
Chemical, but
no, but whenever you have limestone or you have the salts build up in your pipes, that's not weathering. That's the accumulation of the salts. in it.
well, that's what I'm saying. The accumulation is the result of limestone from somewhere else.
Right, the
accumulating.
dissolution.
So that would be a true chemical
Yes.
weathering because that's not pure limestone anymore, is it?
No, and we're gonna look at that process in a bit.
So when it rains and I guess like when there's like carbonic acid, and wouldn't that be,
Yes.
you can like more
That's a
explain
chemical reaction.
as that
Yes.
as chemical?
And that's what you're referring
Yes.
to. Yes, ma'am.
When we go to Enchanted Rock on Thursday, we're not going to climb on top of it, but we suggest that you do so on your own. But there are those depressions at the top, so I'm putting you a question mark. So there's those depressions on the top that I mentioned where my student found a new species of brachiopods on there. So how would you classify those depressions on the top of Enchanted Rock?
That's what Craig was asking about. That's the chemical weathering.
Like this? Like these?
Well, I can't see that, but I'll take the word.
Like a hole.
Yes, like a little pool of water.
Okay, It's been 30 years since I've been there, and so I think though that it's,
She went when you were 1.
there was a lot, yes, when my mother was pregnant. So whenever you get a crack or something in a rock and water sits there, that water sits on the rock and it chemically weathers the rock. It dissolves and it dissolves. So wherever water collects, more weathering is going to happen. So over time, those depressions got bigger and bigger, and so soil could accumulate there, and plants could grow, and so species could live there. Is that what you're asking?
Well, I was trying to relate it back to our field trip on Thursday.
Okay.
And if they go there, they'll see those depressions up there, as well as those layers.
Yeah. And you know, on my trip to Enchanted Rock, I was 14 or something. And that is one of the things that made me want to study geology, because I went with a group of kids and some counselors at this camp I was at, and one of the counselors was like, do you notice how blah, 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 and blah, 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 and explained to me why the rocks were shaped like they were, and why trees would grow here and not over here. I mean, it was just fascinating to me that somebody fed my heart like that and made me want to know more. And so it changed what classes I took because I wanted to know more, and led to me getting a degree in geology. So that was one of the experiences that led me to where I am. Okay, back to here. Okay. On your observations, on your sugar cube, how do mechanical and chemically weathered samples compare? Look at your sugar cubes. How do they compare? We're not writing anything down yet. So just hang tight. So when you physically weathered the sugar cube, you ended up with pieces of sugar cube. When you chemically weathered the sugar cube, was it still identifiable as sugar? Can you look at it and say that's sugar?
No.
No. You could taste it, yes. So it looks different. Okay. So when you mechanically weather the sugar cube, and if you look through your hand lens, you can see that those sugar pieces, when they break off from the original sugar cube or the parent rock, those pieces are jagged. They're all different sizes. They're all different, but they're still pieces of that sugar cube. Poorly sorted means that they all just broke off randomly, and they didn't break off in certain patterns. Like the big ones didn't come off first, and then the medium size, and then the small ones. Lauren? Yes, ma'am.
Well, I don't know if we take too much time, but should we have our smart stuff?
Not right this minute. Yes, you can get those out at the break. Okay. So do you see the halite here? Freshwater stream, after and before. Here's the side view of the same samples. So you can see how deep that hole went when the just drips of water continually over time dissolved it, and the impact of that water caused a hole. Some of the elements that make up this halite were dissolved away and carried away in solution. There's little or no debris, and the solution is carried away by the water. Okay, here's granite again. So this is hard to see, but the stream hit the granite, and over long periods of time, the shape of the granite is going to change because the minerals weather at different rates. Halite is different. It's all one mineral, and it's an evaporite. It was formed from evaporation, and so it's going to dissolve more quickly. ways in which the minerals form help determine the impact of the chemical weathering process. So when granite weathers, the pink crystals in there in your granite, the pink weathers more quickly than the other ones. The pink is what breaks down and turns into your clays in your soil. We talked about the quartz, that takes the longest to weather, and that's why you see the quartz. Whenever you go to a stream bed, you see a lot of quartz in the streams because those weather the slowest. So whenever you go, y'all have seen big boulders, right? And you see that some of the sides might be more angular than the other sides. This is because they didn't weather at the same rate. This is called differential weathering. And the sun has something to do with that, and the water presence. And for example, if you see a big boulder in North America, the southern side of the rock is not going to weather as quickly as the northern side of the rock. Do you have any idea why this might be? No, I'm talking about like a huge boulder. The southern side will weather less quickly than the northern side. The northern side weathers faster than the southern side. Why do you think this might occur? Pam?
I think it's because lichen and moss and whatever is able to grow on the northern side, but on the southern side, it dries out the rock so nothing can live on it or something.
Okay. Anybody else? Toby?
Depending on where the rock is, it depends on the wind, the predominant wind. So here in Texas, we have a predominant Gulf wind. That would be more of an east side as compared to the west side, depending, but that's what I'm getting.
Okay. Melissa, do you want to take a stab at it?
I would say it's mostly because of the fact that it's exposed to more elements. So wind is going to hit more. The sun is going to act upon it more when it rains. That side will typically probably get more rain, so it has more exposed to the elements.
Okay. Well, so think about this. These examples, these models of chemical weathering, what have they all involved? Water. On the northern side, so let's say rain occurs and the rock gets wet. Then the sun comes out. Which side of the rock is going to have the most exposure to sun?
It's facing up.
In the northern hemisphere. The south side will have more, yeah. So the southern side, just a little bit of a difference, but over a long time it makes a big difference. It makes a change. So the southern side is exposed to more sun, so the water evaporates more quickly. The northern side, evaporation occurs less quickly, and so there's more water that sits on the rock for a longer period of time. So while it doesn't make any difference over, say, 100 or 200 years, imagine over thousands of years, you're going to see some significant change on, the differential weathering on these two sides. Okay, on your box and T-chart, now we're on page 2. We're going to summarize what we've talked about, aside from the confusing parts. So we've done a box and T-chart before. The box is for the similarities. So the title of your box and T-chart, is it up there? The types of weathering comparisons. So we're talking about weather, physical or mechanical and chemical weathering. In the box, you write the similarities. Thank you. On the T's, you're writing the differences. Both mechanical and chemical weathering, then make your bullet points. What do they both do?
Break down.
Let me see. Who's going to tell me? Craig.
Sorry, I was writing some notes. I missed.
Both chemical and mechanical weathering, what is the similarity between the two of them?
They both break down the rock.
They both break down the rocks. Something else, another similarity, Quentin.
I put they both, well, all I've got so far is they change physical structure. One of the other ones I was going to write is that water can be an agent in physical and chemical weathering.
Okay, okay. And I'm gonna look that up to clarify, I promise.
No, that's fine.
Okay, Ashley? did you have something?
It happens over time.
Happens over time, okay. Can it happen rapidly?
Physical.
Can physical or chemical weathering happen rapidly?
I guess ice cleaving. Naturally.
When that bulldozer went in,
That
yeah.
can, physical.
Physical can happen quickly. And it depends on the mineral too, right? The halite weathers quickly, whereas the quartz weathers very slowly. Okay, so there's time differences. Okay, now the T-chart. Let's look at some comparisons between mechanical and chemical weathering. Mary Lou, what is one difference between the two?
I'm sorry, I was.
Okay, with chemical weathering, there is a chemical change, whereas with mechanical weathering, there is not a chemical change. Toby, what is another difference?
Whereas
It's just a chemical change. There's something.
I guess I was given the same one, whereas mechanical,
Yes. You want to pass this off?
we take two takes physical objects, whereas chemical would take some type of liquid form. Someone's a solid, whereas another one's liquid.
Okay, that's a good observation. Toby's saying that mechanical weathering looks like a physical it's a solid physical breakdown.
Yeah.
Whereas chemical weathering might look like a liquid, right? Like a solution, something goes into solution.
Eventually, of course, it would be dry,
Yeah,
or be your precipitate.
precipitate, maybe. Yep. Good. Anybody else have something they want to add to that? Dr. West?
I see some conversations at the table that indicates that we still do not have a clear understanding of physical and chemical weathering. And I was wondering, I haven't gotten an answer, I'm sorry, I just thought about it. Perhaps if we wrote some equations or
Like chemical equations?
to indicate it, so it would show the new material,
Okay,
the new chemical. I'll work on that.
okay. Let me get a second real quick. So, as far as the chemical equations, will there be a chemical equation that represents physical? Why? There's no chemical change, right?
Well, nothing else chemically is reacting
Right.
to it or
Right.
with it or.
You could describe it, say there was a rock, and then my hammer hit it, and a piece fell off. That was an example of mechanical weathering. It's that physical change. When you rubbed the two pieces of sugar cube together, there was abrasion, and it was still pieces of sugar cube down on your plate, but it was still sugar. It was a sugar cube, like a rock, versus crumbles of sugar. Yes.
How I'm kind of getting it, because we all know I'm not very great at science, is for physical mechanical portion, something's acted upon it. versus rain, you know, just strictly rain and stuff like that as a, you know, as the acid or so forth. So when I think of chemical, I'm thinking of it's changing its full state. It's not still going to be sugar. It's not still going to be salt. It's going to completely change the state of whatever it is.
Right.
It might break down to smaller elements, but it's no longer granite. It's now granite as a big chunk, but the parts that chemically changed is no longer there, or is some
Correct. So
but mechanical is acted upon, you know, beating with
It's a
the hammer
physical
or
process.
happening, yeah.
Okay, yes.
That's the best way
And
to beat them.
so the chemical process then is, there is, like when you have rain, and rain goes through the air and it picks up the carbon dioxide and you get carbonic acid. That carbonic acid sits on the limestone, and that acid dissolves the limestone, so that calcium carbonate goes into solution, and that's how you end up with the cave systems, right? So there is a chemical change that occurs there. Yes?
During a chemical change, the new compound has different properties than what the original.
Right.
So it's just like what
A chemical reaction.
Yeah.
Yeah, that's good. Thank you. Yes?
Yes, it makes sense now. My other question was that, is it safe to say that the physical weathering, because the example that you use were the hammer and the bulldozer, is that more of something that's man-made versus chemical, to something that naturally happens?
Well, in geology, we talk about it occurring as natural earth processes, but absolutely whenever man breaks apart rocks with a hammer or a bulldozer, you are mechanically weathering. You're really speeding up that process. So yes, we affect the mechanical weathering and the chemical weathering too.
So what's an example of something that naturally happens?
Frost wedging.
All right, so if you have a rock sitting on the top of a hill and that rock tumbles down the hill, not only is it breaking off pieces of other rocks as it goes down, but that original rock, maybe it was jagged, and as it tumbles down the hill, it's breaking off those jagged pieces and becoming rounder and rounder. So eventually, as rocks roll down a stream through the river, they're rounder, right? You see river rocks, and what are one of the characteristics of river rocks? They're smoother and rounder because they've been tumbled through that river, mechanical weathering for a long time. So if you see a rock in a river that's jagged, you can infer that that rock has not been in that river for very long, that it's new to the river, that it's newly weathered into and eroded into the river. Questions? Yes, ma'am.
So is, when it goes in, the water goes down in the fissure and then freezes and then melts again, is that mechanical?
That is mechanical because you are physically pushing that rock apart. You're breaking it into, you're not changing it into a different rock or different, it's not dissolving or anything, it is physically pushing it apart.
So then our earthquake would be the same kind of thing, like that's physically just moving rock and
Yeah.
tearing things up.
Yes.
Or that one.
We just talked about all that. Okay. Water. We talked about water with salt. We talked about water on the graphite, on the granite. And we've talked about water and how it weathers rocks. It is the most important agent that we see in chemical weathering. It involves the changes that alter the chemical and mineralogical composition of that original rock sample. And water combined with oxygen and carbon dioxide are even more potent. And they pick those gases up from the atmosphere. So we're going to look at your sugar cubes again. And you have 2 cups. Can I use yours as well? You have 2 cups. And you're gonna put water in both of them. halfway to 3/4 the way full. Just make sure that you can, this one is not very clear, so make sure you might want to put the solid cube in this one so you can observe it more easily. So you're going to need your phones for a timer. And you're going to drop your sugar cube sediments into one beaker, 1 cup, and you're going to drop a whole sugar cube into the other cup. And you're going to time to see how long it takes each of those to completely dissolve undisturbed just sitting in the water. Okay, so you may want to have 2 phones out and 2 people in charge of the timing.